Good morning. Okay, let's hope to our Lord that I've managed to get my audio issues sorted out. Let's just see if this is streaming live. Okay, just 1 second. It is. I think I'm getting used to the software. It's a bit clunkier than the other stuff. Right, let's see if I can get a link for this. And here we go. I think this is the video link. So what I'll do is I'll paste this in. And then, well, yeah, nobody's going to see anything. 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 Okay, now this should. Okay, now this should. Okay, now it's starting to repeat itself because. Right now, let's have a look. Scene 2, you should now see something really ugly looking. This is my dashboard. What I'm going to do is I'm going to now go to Notebook, and I'm going to go through some of the things that are cropping up in the homework that I set you. Okay, so just bear with me. I can make this more professional in the future. We should have something coming up very shortly. I must remember to get closer and closer to the microphone. There were problems yesterday. Here we go. Hopefully you've got a screen now that's showing something you're all very familiar with, which is Notebook. And here we go. Let's have a look at view full screen. And that's what we're going to be looking at. I don't know if we're going to do all of it today. Let's get that out of the way. That's what we'll be looking at. Now, we'll just give it a few more minutes to see if any more people come online, and then we'll start this. I reckon we'll get through about 6 or so topics. Just check on one of my other devices that everybody can see this. So we're just going to give it a few minutes. Set yourself down, maybe get a cup of tea, pen, paper, calculator. Now, YouTube deleted one of the videos because it was static for too long. There was no interaction. I don't know what that was or why that did that. Maybe to save bandwidth. Okay, we'll start the broadcast at 08:40, which is when your lesson would have begun. Spare me 1 second. I'm just going to get my phone. Let's write some notes. Right, I'm just going to let your teacher for today, that's if you're in school, now, oh sorry, I'm miles away from the, right, now must remember to keep close to the screen. Okay, I make it 08:40 on the 20, no, I'll make it 08:39. Just bear me 1 second. And so 08:40, I shall begin. Just see. Okay, 08:40, I make it. Right, now, I've set you some additional homework. I'm not entirely sure how the school's going to use it, so I wouldn't panic. I think I'll be very careful what I'm saying. I think it will be important-ish, so it's worth doing. I think there's many reasons or many ways they could use this homework. I really don't know, and I'm very worried that I might worry you, which I probably just now achieved. Look, here's some homework I've set you over the next few weeks, and I just want to run through some of the topics. I'll keep it as simple as that, and I think it's worthwhile doing this. How about that? Okay, the first thing we're going to look at are quadratic simultaneous equations. So, just a reminder of what they look like. This is an example of a quadratic simultaneous equation. Y equals 2x squared minus 5x plus 7, and at the same time y equals, I don't know, 3x plus 5. How do you go about solving these? Well, first things first, we're going to label them, equations 1 and 2. And if they both begin with y, then the technique we're going to use is we're going to equate 1 and 2. Now just bear with me, I'm trying to see how good or otherwise this recording is via another device here I've got. It's mainly the sound that I'm concerned about. Tell you what, in fairness to Our Lady, we're just going to change the image now, and we're going to remove her. Blessed. That was just for the beginning of the show, okay? So, here we go. Right, I can't... Once I get this all off pat, it'll be a lot better, God willing. Actually, I see some people already logged out. Don't blame you. Maybe you can't hear anything. Let's have a look. So I'm just trying to get. So if you hear something in the background, that's me on my tablet trying to work out how good the quality of the sound is. Right, let me just. All right, okay, that isn't too bad. So, if there's anybody still watching, which I'm not entirely sure there is, there were a few more earlier. Don't blame you, to be honest. Okay, now I think it's. I think I'm going to turn off my tablet now so you don't get this echo. Spare 1 second. That's Mr. Edison. Okay, now for those few that are still watching, here's what you do. You equate equations 1 and 2. Now, what does that mean? Well, it means you show that they are equal. So, equation 1 and 2 are both equal to y, so they must both be the same. So the next step you do is you write down 2x squared minus 5x plus 7 equals 3x plus 5. Okay, if they're both equal to y, then the expressions that they're equal to must equal each other. The next step is to rearrange it, get all the x squareds on one side, and we want 0 on one of the sides, and our expression on the other side. So let's write that down, 2x squared minus 5x plus 7, take away 3x, take away that 5, so these terms here have moved to the left, equals 0. Then simplify it. I think I'm going to get away from full screen. It just makes it a bit harder to get all my colours and what have you. Then we're going to simplify, look for like terms, and we get 2x squared minus 8x plus 2 equals 0. Now, the work I've given you is calculator based. So we're going to use our formula. So a equals 2, b equals minus 8, put it in a bracket, c equals plus 2. Put the negative terms in a bracket. Okay, it might sometimes be unnecessary, but it can never do any harm. Leaving out the brackets could. Then we're going to use the formula that x is equal to minus b plus or minus the square root of b squared, take away 4ac. Now, if you've joined late or you've had problems, what have you, don't worry. This will be uploaded. So just a reminder, here's the formula. And should you have got to this stage, then all you have to do is replace a with 2, b with minus 8, and c with plus 2. And what do we get? We get minus 8 plus or minus the square root of b squared. So that's minus 8, put it in those brackets, take away 4 times 2, which is what a was, times 2, which was what c was as well. Okay, it's a fair bit of work, but you know, there'll probably be a fair few marks. And then 2 times 2, that's our 2a. Right, that's the important bit you have to write down. Now, it's a big fraction, so we're going to type in minus 8 plus, we'll come back to, it said plus or minus in the formula, we'll replace that plus with a minus in a moment. Minus 8 all squared, take away 4 times 2 times 2, all over 2 times 2. Yeah, there were some shortcuts there, I could have worked out some in my head. And we get 2 plus 3. My mistake, 2 plus root 3. And let's go back and change the other one. that plus sign to a minus, and you get 2 minus root 3, which is what we probably suspected. So the values of x are 2 plus root 3 or 2 minus root 3. But we're not quite finished. To solve a simultaneous equation, you've got to find both what x is and y is. Now, as we've got two values of x, we're going to find two values of y. How do we find those? We go back to one of the formulae. I'm going to use the simpler one, the y equals 3x plus 5. And I'm going to use that to find out what is the value of y when x is 2 plus root 3. So, do that. I do 3 times brackets 2 plus root 3, because that's the value of x I'm using. Add 5, and we'll probably get another third. Yeah, you get 11 plus 3 root 3. And that's the value of y when x was 2 plus root 3. What about when x was 2 minus root 3? Use the same formula. In fact, I've got it up there on the screen. All I've got to do is change that plus sign to a minus, and we get 11 minus 3 root 3. And they are the two values of y for the two values of x. Okay, so run through that again. The key bit is you equate the two equations, rearrange it to make it a quadratic equal to 0, quadratic expression equal to 0, quadratic equation, then use the formula as the simplest bit. All right, let's go back to the topics that we're going to look at. I'm just going to delete that page. It's going to irritate me. I might as well delete that one. Why am I going to delete that? I don't like the look of it. There you go. Area and surds. Now, this is an interesting question that's coming up on the paper that I've set. Let's clear this. Here you go. I'm not going to go through the exact same one, but here you go. Let's have a look at this. Here is a square with an area. The area of the square is, I think, it's 20 centimeters squared. Let's say this distance here is 2 root 7 centimeters squared. We're going to try and find the area of the triangle. Ooh. Well, let's remind ourselves of the area of the triangle when we know, if we know, two of the lengths, the base and the height. The area is a half times the base times the height. I'm going to use this for my base, but what's the height? What's this length here? Well, I don't know at the moment. However, if I've been told that this bit here, the area of the shape that borders it, is a square, then I can work out what each of the lengths of the square is. Now, if the area is 20 centimeters squared, then the area is formed by squaring each side. I'm going to call each of these sides x. So x squared must equal 20, so x equals the square root of 20. Let's just, if we've got a calculator handy, which you will have, let's see what that is in surd form. There you go, it's 2 root 5. So the height of the triangle is 2 root 5. So now I can use that to work out the area of the triangle. The area is a half times the base, which was 2 root 7, times 2 root 5. Now the good news is, as I say, we've got a calculator. So I'll do a half times 2 root 7 times 2 root 5. Make sure that when you're typing in the information, you move the cursor after entering the third. And there you go, it's 2 root 35, which you probably could have worked out, many of you, without a calculator. Okay, so recap. Just use the basic formula for a triangle. half base times height, but look out for where the area is a square, and you have to calculate the square root of whatever that is, and that will give you one side of the triangle, the missing side of the triangle. Now, let's have a look. How are we doing? Are there any viewers here? There are 2 people watching. I don't know if comments are allowed. Not entirely sure. Just bear with me 1 second. Just have a look, see if this gives me any info. No, it doesn't. I'm just going to have... No, I won't do that because I think there's some security issues here. Right, now, vector algebra. Let's deal with that. It's the classic question like this. Okay, here you go. Let's label the sides A, B, not the sides, the corners A, B, C, D, and let's have X and Y. And here you go, here's some more information. AX equals 2 times XY equal to YC. And we'll also put some letters on here, okay? This is the vector P, and that one's the vector Q. Just bear with me a second, I'm trying to think how like. Actually, I'll tell you what, let's make it a bit easier. And that one there is Q. Okay, first type of question might be, find the vector A to C. Now remember what you do, you think of how, using the letters they give for the vectors, how can I get from A to C? Now I go from A to B and then B to C. So the vector A to C is P plus Q. But now comes some tricky bits. It's more to do with ratio. Let's look at this information that was given here. AX equals 2 times XY equal to YC. What on earth does that mean? Well, it means that this length here is twice that length there and equal to that length there. So let's make it a bit more representative. The length AX is twice the length of XY. So let's see if I can get my head around this. If I call that length L, then that's 2 lots of L, and that's 2 lots of L. Let's just double check we've got that right. AX, this length here, is twice XY. But AX is also equal to YC. Now, whoops. It's best to think of it as fractions of the whole length. Look at this whole length here, A to C. What fraction of the whole length is A to X? It's 2/5. Where did I get that from? Well, I added up all my L's, and there was 5 L's. This is 2 of the lengths out of the total. This must be 1/5, 1 L out of 5, and then 2/5. Now, why is that important? Well, let's look at some other vectors we're going to find. We're going to find the vector AX. Now, AX is this journey here. It's the journey from A to X. And it's 2/5 of the whole journey of A to C. We just found out A to C. So the vector AX must be 2/5 of that total journey. And the hard work with this type of question is interpreting this information here. Let's look at another question. Let's say we're asked to find the vector CY. Now, I've worked out how to get from A to C. If I knew what C to A was, then I could put 2/5 because that's the fraction of the journey I'm going in front. Cy is equal to minus, beg pardon. Yes, Cy is equal to, well, hang on, muddling this up a bit. The vector A to C we found is P plus Q. So the vector C to A, I'm labouring this, I'm sure most of you are ahead of me, is the opposite. So it's minus P plus Q, close brackets. So if I know what the vector C to A is, how to get from C all the way to A, and it's minus AC, then what's the vector CY? The vector CY is a fifth, my mistake, 2/5 of the journey from C to A. So it's 2/5 minus P plus Q. Now, some of you are immediately saying, that doesn't look right. No, it's 2/5 times that. Now, if I wrote that down, it looks like 2/5 take away that, which wouldn't be a vector. So, the best way to write it is minus 2/5. Put that minus sign in front of the whole thing. And strictly speaking, all vectors should have a little squiggle underneath. Right, I hope that's just reminded you of how we can do these vector type questions. Vector algebra it's called. Now, how are we diddling for time? Well, we've done 20 minutes, and this is a bit intense, so I won't, do much more than half an hour max. Solving equations is the next thing. Now, surely in a higher paper we're not doing linear ones, we just looked at quadratic simultaneous equations. This is the type of thing I'm looking at, getting used to do, okay? X, 2x minus 1, 3x minus 8, I don't know, and x plus 7. And this one here is 4x minus 2, x plus 3, and 3x plus 15. And you're told that the perimeter of the quadrilateral, it's the one I just highlighted in yellow, and the perimeter of the triangle, the two perimeters are the same. Now, how you solve an equation like this is, we're going to find x, is we're going to equate the two, because the question has just told us, well, I've just told you, that the perimeters are the same. So let's first work out the perimeter of the quadrilateral. It is x plus 7 plus x plus 2x minus 1 plus 3x minus 8. You probably didn't need to write all that down, because what you would do is, we're going to simplify it. Okay, so gather together all the x's, and we get 7 lots of x, and gather together all the numbers. 7 minus 1 minus 8. Use a calculator if you're not sure. That gives us minus 2. What about the area of the triangle? My mistake, the perimeter of the triangle. Well, let's simplify it from the diagram. Here we've got 8 x's, and we've got plus 15, plus 3, and minus 2. So plus 16. I think I got that right. And then you equate the two. 8x plus 16 equals 7x minus 2. Now it looks to me like it's going to be a negative number, so I really didn't think that question through. But anyway, that's the technique. The method's correct. When you rearrange it, you're going to end up with 8x minus 7x equals minus 2, take away 16. X equals minus 18. Which in this context is impossible. Okay, so but when you come to a question like this, you should find that it is a positive answer. Right, so that's what I meant by looking at solving equations. Next one we're going to look at is simplifying with powers. A quick overview of what you do here. Here you go, x to the power of 4 all over x to the power of 3, all itself raised to the power of minus 3. Well, how could you go about this? There's a number of ways. Firstly, as both of these are the same letter, why don't I just simplify it as x to the power of 1? And then remember the rule. X to some power, itself all raised to another power, gives you x to the, is it a plus b or a times b? It's a times b. So this would be x to the power of 1, all to the power of minus 3 to give x to the power of minus 3. There it is, all simplified. I'll go through that again. So let's say your question was this: m to the power of 7 over m to the power of 9, all to the power of minus 2. Well, we'd simplify the bracket first. M to the power of 7 divided by m to the power of 9 is m to the power of minus 2. And then remember, you multiply these indices and you would get m to the power of plus 4. Get your calculator to double check it. Should they give you one like this, a to the power of 4, b to the power of 3, all to the power of, I don't know, minus 5, then there's not much you can do here. You would just multiply both the indices by minus 5 to get a to the power of minus 20 over b to the power of minus 15. Right, now let's clear that page. We're getting to the maximum amount of time I think that your brains can cope and your ears can cope with listening to me. Simplifying algebraic expressions. Here we go. This is the last one. 5 over x to the power of minus 3 minus 2 over x plus 4. And I want to write that as a single expression. First things first, put brackets around those two-term expressions. Let's just go back to when we're doing fractions. If I had 5/7 take away 2/3, one technique that I could use is to cross multiply. And that's what I'm going to do here. But be warned, there's a minus in front of that 2. We're going to treat that minus, one way of reading it would be 5 over x minus 3, take away 2 over x plus 4. But I'm going to now treat that minus as being closer to, part of the 2. So it's actually minus 2. Let's run through and see what happens. So we're going to cross multiply. So we're going to get 5 over x plus 4 minus 2 times x minus 3 all over those two brackets multiplied together. Now, in the old days when they used to assess pupils by exams, that would be worth a method mark. Now, what we're going to do is we're going to expand each bracket on the top, and on the bottom we're going to multiply the two brackets. Let's have a look what we get. You get 5x plus 20 minus 2 times x. None of you make a mistake there. But then minus 2 times minus 3 is plus 6. And then on the bottom here, well, we'll use our quick technique. X squared. Then the way to find out the number in front of x is add those two together. So it's plus 1x or plus x, and then minus 3 times minus 3 times plus 4 is minus 12. And all we're going to do to finish off, to finish this question, is simplify the top. I can't simplify the bottom. And you get 3x plus 26 all over x squared plus x minus 12. Voila. What's the time now? Now, this broadcast has been going on for 27 minutes, and me rattling through some maths. Dare I do one more? Let's have a look. How many have we got to do? Oh, we'll do one. Oh gosh, did I really set that much work? Sorry, everybody. Right, tree diagrams and conditional probability. Here we go. 5 minutes max. Let's look at a type question. Okay, Ben. I don't know why they don't just say somebody, but anyway, they think of some names. Ben has a bag of socks, 3 yellow, 2 white, and 5 black. Chooses 2 socks. So he chooses them and keeps them. He doesn't put them back in the bag. Probability. Right. What is the probability? Well, we'll come to the questions. Let's get the tree diagram sorted out. Right, this is probably the limit of tree diagrams as we were looking at, because it's got 3 branches for each choice. So let's look at his first sock that he pulls out. It could be yellow. Wonderful use of colours there. It could be white. Well, that's not box himself in. There is no white. It could be black, or it could be white. Any colours anywhere in it? Anyway, look, you're not fussed about that. Okay, why I chose. Look, doesn't matter why I chose green for white. He could have chosen a yellow sock, a blue sock, and nope, a white sock and a black sock. What are the probabilities? Probability of yellow is 3 out of the 10 that are in the bag. Probability is white is 2 out of 10, and the probability is black is 5 out of 10. But what about the second sock? Now he hasn't put them back in. So let's have a look what happens after he chooses a yellow one first. So we'll label the possible outcomes Y, W, and B. The probability if he chose a yellow one first, when it comes to choose a second sock, there's only 2 yellow ones now in a bag of 9. What about white? Well, if he chose yellow first, it hasn't affected the number in the bag, so that's 2 out of 9. And how many black stocks are still in the bag? 5, but there's only 9. So had he chosen a yellow one first, these are his probabilities. And now do you see what I mean about the limits of tree diagrams? Let's see what happens had he chosen a white sock. What's the probability after choosing a white sock? The second sock is yellow. Well, there's 3 yellow ones out of 9. The white ones have gone down by 1. Remember, there's only 9 socks now. And in the black, the probability of a black sock is going to be 5 out of 9. And then we'll just finish off our tree diagram. It's a problem about recording it live. I could have rehearsed, I guess. Right. He's chosen a black sock. What's the probability of choosing a yellow sock second? It's 3 out of 9. The white ones haven't changed either. That's 2 out of 9, then 4 out of 9. Now, let's look at a simple question that could follow on from this. What's the probability that he chooses 2 yellow? Now, the way you do it is this. You trace the path that would lead to success of finding 2 yellow socks. So it's there and there. And then you write down the numbers on each of those branches, 3/10 and 2/9, and then you scratch your head. Do I add them or multiply? You multiply. So it's 6 out of 90. The probability of getting 2 yellow socks is 6 out of 90. But what about a harder question? What about the probability that the socks are the same colour? Now this is where a bit of brain power is involved, or needed. They're probably the same colour. That means that both are yellow. We just worked that out. Or that both are white, or that both are black. So we'll find out the probability that both are white. So it's going to be 2 over 10 times, is that a 1 over 9? I believe it is. Multiply those together, 2/90. The probability that both are black is, let's look at these numbers here. We've got 5 over 10 and 4 over 9 to give 20 over 90. Now, but what's the probability that we need to write down to answer the question? The probability that they are the same colours. Well, we've got the probability that they are yellow is 6 over 90. The probability that they're white is 2 over 90. The probability that both are black is 20 over 90. This question, what's the probability that the socks are the same colour, could, with a moment's thought, be the probability that both are yellow, or both are black, or both are white. Now the word or, you can remember, means you add the probabilities. So to finish off, you would add all those probabilities, 6/90, 2/90, and 20/90, to give 28/90. There you go. That would be how you'd answer that question. It used to be called a grade A star, which is a 7 or an 8, because of the fact that he hasn't put the socks back. Right, okay, now I hope the sound quality wasn't as bad as it was yesterday, and I hope this has been of some use. I will broadcast again tomorrow, the second half of dealing with questions that are going to come up in the work I've set, and I'll do that at the same time as we had lessons on, oh no, not Wednesday, it would be, let's have a look at this, it would be Thursday. And what time am I going to broadcast? Let's just check. When was your lesson due? Your lesson on Thursday was 11 o'clock. I'll be broadcasting tomorrow at 11 o'clock. Okay, thank you. I hope it hasn't been as bad as yesterday's broadcast.